Today we're going to talk about channel probing attacks, and we're going to try to do it ourselves. Uh, Jonas told me that you guys had this as pre-work, and I actually think I sat in while you talked on it. So he said, don't worry about reminding them how channel probing attacks work, but I thought I would remind you how channel probing attacks work before we get started so everyone's on the same page. So let's talk a little bit about privacy on the Lightning Network first. Um, so the precise channel balance of any given node is actually a secret on the network. Hopefully, you don't want to tell people exactly how much um, balance you have between the two nodes in the channel. Uh, the only thing that we do know on the network is the maximum capacity of the channel, and nodes have the ability to ask for you to route something through it. So you kind of get this binary like, yes, I can route it, or no, I cannot. And you know the maximum amount that it could possibly route. If we were to say, all of the balances of all of the nodes on the entire network, you could actually kind of reverse engineer transactions out of that and see where money's moving and de-anonymize people or figure out what they're buying. So that probably wouldn't be a good thing. Um, this causes routing to be slightly less efficient since we don't have this perfect topology of the network, but it's a very valuable trade-off to maintain the privacy of nodes on the network. Um, Unfortunately, it's not a perfect state of privacy because we can do this thing called a channel probing attack. So in this instance, we are you, the user, and we want to know what's going on between Alice and Bob. We know that they have a capacity of 100 coins, but we don't know what their current balance state is. So the way that we would actually do this is we would open a channel to Alice. This could work with Bob as well. You could attach to either, and we're going to make sure that we have as much capacity or more that Alice and Bob have. Then we're going to try to route a payment from us through Alice to Bob. And so first, we're going to start with the maximum amount. We're going to say, hey, I want to send 100, and Alice is going to tell us, sorry, I can't do that, Chief. Um, don't have enough capacity or don't have enough balance currently. So then we'll try another one and another one. But you see, we get different errors, even though we're getting, in all cases, we're going to get errors back. We're going to get a different error if it could route the payment because what we're doing is we're inventing fake payments. We're coming up with our own payment hash that Bob didn't actually uh, authorize or isn't checking for. So the first one, we got an insufficient balance error, which meant that Alice couldn't route the payment. But then when we tried 50, we got a different type of error. We got a invalid payment hash error, and that one actually came from Bob. So the payment went through Alice. Alice handed off to Bob. And Bob said, "What is this? Like I've never seen this before." So by checking these errors, we can know when it's an insufficient balance, we should try less, and when it's an invalid payment hash, we should try more. And so we can keep doing that, and so on and so forth, until we get an insufficient balance, and then one Satoshi less gets us an invalid payment hash. That tells us that the balance is currently between 94 and 95 Satoshis. There are millisatoshis in there, so that's why I will say between probably 94, but it could be some change on the end. So with that, we have found out that the balance between Alice and Bob is 94 coins. So why does this work? Why doesn't Alice just say, "Hey, that's a fake payment," or um, Bob just not tell us what's going on? Uh, so we can always open a channel to Alice pretty much because nodes love channels. They love inbound capacity. You're paying chain fees to make their routing experience better. So no one's ever going to reject a channel from you in most cases. So Alice won't stop us from connecting to her. Um, the nodes that you route through don't actually have all of the data that you as the sender typically have. So as we just talked about with Bolt 11 payments, that is signed by the recipient. And so that's how we know what node we're routing to. But everyone along the route doesn't have that same Bolt 11 invoice. They don't have some kind of signature from Bob saying, I totally authorize this payment because we're trying to keep Bob private. But that means that the nodes along the way can't validate that this is actually a legitimate payment that Bob will receive at the end because Bob wanted it. So we can easily fake um, information from Bob because things along the way are not signed by their private key. Um, And one thing that makes this really easy to expand to the network as a whole is hub nodes have great connectivity. So from that paper that hopefully you had a chance to read before, but we can get 50% of channels just by having connections to 18 nodes on the network, and 80% of the channels with 78 nodes, so on and so forth. This has probably changed a little bit over the last few months. This was from January, but the idea is basically that given the sort of hub and spoke shape of the network, you don't need to connect to every single node to start getting the balances of most of the network. So we are going to do this ourselves. We're going to do a little channel balance attack, but we've mostly been nice people for this residency, except for maybe the last previous one. So I just want to get everyone in the right mood. We're going to be hackers now. We're going to be bad guys. I thought maybe just seeing some hacker imagery would get you in the right mindset. Run some Darude Sandstorm, a little orbital, and let's get going. Um, so I want you to head on over to this GitHub repository. I could probably it'd be better if I drop the link in the chat. I'll cool. Thank you. Um, just crack that open. I'm gonna walk through it together with y'all, but you're gonna be sort of basing your attack off of that.
So just a question.
Yes.
The number of 50% and 18% or whatever they were.
Yeah.
That's because the hub was sort of the smallest channel along the route, or what? Why? What's the limit?
Oh, the idea there is that like the topology of the network is the majority of nodes route to these big nodes like Pierre's power user node or the y'all's node. So if given that you have to open a channel for every to every node that you want to scan its channels of, that might be prohibitively difficult from a cost standpoint. But because there are all these hub nodes that are so well connected, if you wanted a really good view of the network, you wouldn't have to connect to that many.
Because I have what I'm calling keyhole attack here, that would allow you to. So the problem with this is basically that as you go along a route, you basically are always restricted by the smallest capacity, right? But what you can do is basically follow that sort of funnel, and then the channel that you're trying to probe, you can bounce back and forth.
Gotcha.
And then that allows you to even probe a larger channel behind a smaller one, and that's not in the paper.
The paper, honestly, yeah, actually, I would say that would probably be a good topic to cover. Yeah, in the assumed attack that we have here is just a 3-node setup. So I for the purposes of keeping this simple, we're just using Alice as the intermediary. But you're right, you totally could route through multiple nodes, and there are ways of.
Yeah, but what I'm saying is that the channel between U and A could be 10 satoshis, and I could still probe the entire capacity on the other side
Just by using like hold invoices?
By bouncing back and forth multiple times and multiplying my own capacity.
I see. So you send a route of up to 20 bounce. Okay. No, they did not mention that. Oh, that's pretty awesome. Yeah, please do. Apparently not. Anyway, so popping over to this repository, I am a nice and caring person, and I decided to do the code in both Node with TypeScript and Python because I knew there would be some groans about having to use Node for this. So it's a pretty simple setup here. You can run through the README to set it up. Do that on your own time. The basic gist is that most of everything happens in either scan.py or scan.ts. That's the code that you'll be running. Let's just do a quick run through, like block by block, just so that there's nothing in there. It's too mysterious, and y'all can ask questions. So the examples are going to be in JavaScript, though, so you're going to have to deal with me on that. So initially, all we do is we grab some information about our node. So we're going to grab a list of our channels and find the channel that we're looking for. So you're going to pass. Actually, it would just be a lot easier if I ran this first, so that you know what it should look like, and then you'll understand the code a little better. So the idea is that you are going to run this command scan channel that we've built, and the first argument is going to be your channel ID to Alice, and then the second argument is going to be the channel ID of Alice to Bob. So you're going to have to do, at least for this initial run, a little legwork to look these up. 1ML is a pretty good resource for that if you don't have your node hooked into some kind of GUI. And so once you run this, it will begin the scan. So this is a channel of 200,000 Satoshis, so it'll start in the middle. And the amount was too high, so it'll go down to half of it. Yeah, right. Yeah, it's definitely there is room for improvement. This is a very naive implementation. I was not trying to get fancy here. Anyway, as you can see, it takes a little while to get responses from everybody. It's unfortunately not quite as snappy as we would hope from the Lightning Network. But anyway, I'm going to let that run. But that's what we're doing here. So the idea is that we grab our channel. You need to, at least for this code example, we're using LND. But if you wanted to write this from scratch and just use mine as a baseline, you could totally do this with Eclair or C Lightning. But we're going to grab our channel, and then we're going to grab the channel that we want to probe. And if for some reason you don't have an ID that returns, it's just going to throw. We're going to determine the max amount we can scan. There are three possibilities for what the maximum amount could be. It's either going to be your channel's capacity, because we're not fancy like Christian and aren't going to be doing this keyhole probing. It is either their channel capacity. Sorry, it's either their channel capacity or your local balance, because you can't use your just your capacity. You also have to have balance on your end. So you're going to have to open the channel. So it's either their capacity, your local balance, or the max payment size, which is roughly 4 million Satoshis. I just made it a constant here, so we didn't have magic numbers floating around. And then we're going to figure out the destination's pub key. Yeah, what's up?
So this is, I have a question regarding the keyhole attack. Maybe I think it's better if I ask now.
Yeah, by all means.
So why does a node allow me to route through the same channel multiple times with the same payment hash?
Because we don't currently have the short circuiting. Eventually we should do that. In that case, you would need to loop out, and then it could work.
The current I can actually have both HCC.
So the reason why we don't deduplicate currently is because that would break AMP as well.
Cool.
All right. Then we just while loop over and attempt payments, and then adjust the amount. So we're going to start with the lower bound being 0 and the upper bound being the maximum amount that we just determined. And while there's a difference between the two, greater than 1, we're just going to find the middle, try out a payment, and then grab the error. Unfortunately, LND has these really crappy string errors. So we have to parse a string to figure out why it might go wrong. And I found that there are many reasons why it might go. It might report many reasons why it might go wrong. These ones, but those all meant that the amount was too low, or sorry, too high. And then if there's some unknown error in there, we're just going to bail out. So that could be like a network connectivity error, or this channel doesn't exist. Right? Yeah. Lots of things could go wrong in here. So that's really all this code is doing. So what I want you guys to do is follow the README in the repository. You can either do the Node or the Python version; they're identical. Hopefully, you did this before. I asked y'all to do this a couple days ago, but you got to open a channel of greater than or equal to 0.05 Bitcoin to my node, which you can find. I dropped a link in the chat yesterday, but you could just search for me there if you don't want to look that up, and make sure you connect to the right port. For some reason, 1ML just uses the default port, even if you're not using the default port. And what I want you to do is I want you to scan my channel with this node here, dead.cache. So there's a channel ID conveniently for you. I'll paste that in the chat as well.
Won't result be skewed if we all try to pro at the same time?
Oh yeah, I guess that's a good point. I didn't consider. All right, you can pick any channel you want. Doesn't have to be that one. Again, yeah, it might affect it. I did at some point try to parallelize my searching, and I found I ran into that. Is that while you have payments in flight, it won't let you try to pay them again. So that's a very good point. Maybe just try a random channel, not necessarily that one. There are plenty. You could even target one of your cohorts here. And so once you've gotten that running, you've gotten it to run once. I would like you all to try to change the code so that you don't have to give 2 channel IDs. You just give a node pub key, and then you scan all of their channels, since that would probably be more useful. So you're going to want to change this code, or you can start from scratch if you want. But the idea is you want to just punch in a pub key that you have one channel with, and then get back results of all of the balances of all of their channels, as it is, and hopefully optimize the algorithm, because this is very naive little binary search, and I'm sure there are a few cases that you can account for that should make it go faster.